All right, Math 2, here we go. We've got 7-5 tangent ratios. Make sure you put your name and your period on your paper. Our question for today is in a 45, 45, 90 triangle, the tangent of 45 degrees equals 1. Explain why that happens. Why is that true? Okay, so what we're in right now is a section called trigonometry. Trigonometry is, in math, it's the study of right triangles. So all the things that happen with right triangles, why are triangles so important, is because triangles pretty much can be found in every shape you can think of, even in circles. So triangles are super important. All right, so we're going to be looking at ratios, which are just fractions. So we're going to look at fractions comparing different sides, and we're going to find out they can be used to solve for other sides or even angles using similar triangles. Remember, similar triangles had a scale factor. So what we're really going to be looking at here is scale factors of different types of triangles and then setting up ratios to help us solve for those. All right, so how do we set up a trig problem? All right, so setting up a trig problem requires just it's the same setup for each type of trig problem that you're going to do. What we'll do here is we're going to write down our trig function first. And for this unit, we're going to use 3 different trig functions, and today's is tangent. So the trig function, when I say that, you're going to either write tan, sin, which stands for sine, or cos, which is cosine. So you're either going to, when you're setting up these problems, you'll write down a trig function of some sort. Like today, we're only going to work through tangent. On our next lesson, we'll talk about sine and cosine. So for right now, when we set up a problem, the first thing that we write down is a trig function, tangent, sine, or cosine. Next thing we do is an angle measurement. So the angle that we're using for the trig function, that's what's going to come next. And then it's always going to be equal to a ratio, so a fraction of the sides. So we're always going to have it equal to a fraction of a side divided by another side of the triangle. Okay, so that's how we're always going to set up these problems. Okay, we're going to take it really slow. We're not going to solve anything until later on. We're going to really just focus on how do we set up a problem first. Okay, so let us say that I am looking at this 40-degree angle. So if that's the 40-degree angle, we would call this the opposite leg. Because that's the leg that is not touching that angle. We would call the other leg the adjacent leg. And then, of course, this one would be the hypotenuse. Now, tangent's only going to use the opposite and the adjacent leg, so we're not going to worry about the hypotenuse for today. But here's the other thing. That's only when we're looking at the 40-degree angle. When we're looking at the 40-degree angle, this side is my opposite leg, and this one's my adjacent leg. But if I were looking at the 50-degree angle instead, then this one would be the opposite leg instead of the adjacent leg. And then this one would be the adjacent leg because it's the leg that's next to the 50-degree angle. So which angle you're looking at decides which leg is the opposite leg and the adjacent leg. Because the adjacent leg for one of them is the opposite leg for the other one. So you have to watch out and decide on which angle that you are focusing on. Are you going to focus on the 40-degree or are you going to focus on the 50-degree? Because that will change what we're doing here. So what we're going to do is we're just going to set up how we would do these problems. So the tangent ratio is always going to be the opposite leg divided by the adjacent leg. Okay, so if I were looking at the 40-degree angle right there, then I would say the tangent, because we set up the trig function first, then the angle, so the tangent of 40 degrees, would be equal to, which leg is the opposite one? Well, the opposite one is BC. Which one's the adjacent one? AB is the adjacent one. Now, we're not dealing with numbers here. We're just showing you how to set up the problems. Okay, this is all set up. We're not actually solving anything. So that's what the tangent of 40 would be. It would be this leg over this leg. That's what it would be equal to. All right, what about the tangent of 50? So if the angle that I'm focusing on is this 50-degree angle, again, tangent is opposite leg over adjacent leg. Well, the opposite leg is now this one over here. So AB is the opposite leg, and the adjacent leg is now BC. And what you see here is these are reciprocals of each other. So the tangent of one angle is the other angle's reciprocal. So we flip them around. All right, again, now I'm going to put some numbers in there. So I'm just kind of building this up one thing at a time. We're just going to kind of put some numbers in here. Okay, so let's say that I was focusing on angle A, and that's my angle that I'm talking about. So let's say if I wanted to do the tangent of angle A. Okay, so we'd have to say, okay, what's opposite? Opposite would be 15. That's the opposite leg. So I'd put 15 on top. What's the adjacent leg? The adjacent leg is AB, so that'd be 8. So it'd be 8 or 15 over 8. Okay, so we could actually get a number from that. If I did 15 divided by 8, that would be 1.875. So the tangent of A would be equal to 1.875. Have we solved anything yet? No, we're just still setting up the problems, showing you how to set them up. Okay, what if we wanted the tangent of C? Well, the tangent of C, the opposite leg would be 8. The adjacent leg would be 15. So 8 divided by 15 is 0.53 repeating. So let's just say 0.5333. Normally when we do the ratios, we usually do it to the nearest 10,000th place. So 4 decimal places. Okay, we haven't solved anything yet. And some of you might be scratching your heads and going, well, what is this tangent and what is this ratio? Why are we setting up these fractions? What are we actually doing here? Well, every triangle that is a 40, 50, 90 triangle is similar, right? Because similar triangles have the same angle measurements. So that means there should be a scale factor here, since these are similar triangles. And what we have here is the tangent of whatever angle we're looking at is the scale factor of that angle. Because remember, the scale factors mean that you can blow something up by multiplying or shrink something down by dividing. And your calculator with sine, cosine, and tangent has all those scale factors already programmed into it. So any angle that you can think of, the scale factor is already inside of your calculator under tangent, cosine, and sine. There's a lot more to it, but for right now, that's all you need to know, is these are all the scale factors. Now we're going to use that to actually solve a problem here. Okay, so we've learned how to set them up, how to find a ratio. Now we're going to actually learn how to solve these types of problems. So in this first problem, I've got 58 degrees. So that's going to be the angle that I'm focusing on. And over here, this would be the opposite leg. And this one would be the adjacent leg. Okay, so I'm going to set up a trig problem. I only know tangent right now, so let's do tangent. So tangent of 58 degrees. Now you got to remember, every triangle that has 58 degrees in it and 90 degrees here will have the same angle over here because of the triangle sum theorem. So this angle would have to be what, like 32? So every triangle that has 58 and 90 here is going to be similar. So they should have some kind of scale factor between them. That's what the tangent of 58 is. It's the scale factor of that type of triangle. Now, it's the scale factor of the opposite side, opposite leg, over the adjacent leg. So what's our opposite leg? Our opposite leg is x. What's the adjacent leg? 11. Now we want to find out what x is. Well, I have my scale factor here. So that's going to be some kind of ratio, like we were doing over here. It's going to be some ratio. So if I want to get x by itself, what I can do is multiply both sides by 11. So of course, these 11s would cancel out here, and I'd get x is equal to 11 times the tangent of 58, which is the scale factor of that type of triangle. Any triangle that has 58 degrees in it and 90 here and 32 here is going to have the same scale factor because they're similar. So this is like the scale factor. So I can just multiply 11 times that scale factor, and that should give me this size right here. Now your calculators have all this built in. So we can just do 11 times tangent 58. We get 17.6. So that side would have to be about 17.6. It's not exact, but it's close enough. So squiggly line. Okay, now not all calculators calculate the exact same way. If you've got a calculator like this, I kind of like the TI-30XS, you can just type it in exactly as you see it. However, some of you will probably be using the calculator that's on your phone. The calculator that's on your phone does it a little bit differently. So the first thing you're going to want to do is spin your calculator on your phone to the side like this. And you can see here that it says sine, cosine, and tangent. Now make sure that you don't have this RAD button. Don't have that up there. If you've got RAD up there, it's going to give you the wrong answer. We want it in degrees instead of radians. So we're going to click degree. Make sure that it's just blank up there. Because if it's in radians, your answer is going to be completely different. That's going to be something that you get into in like advanced math, like or you might call it trigonometry, depends, whatever. Well, we're good. Just make sure that it says RAD here, because if you click on it, then RAD goes up here. It means that you're in radians. So you want to be in degrees instead. If you don't do that, you're going to get the wrong answer. So how would I do 11 times tangent of 58? Well, on your phone, you actually do everything backwards. You do 58, so I'm writing 58, and then I find the tangent of that. So tangent. So it gives me the scale factor of a 58-degree triangle right there. The scale factor is 1.600, blah, 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 blah. All right, and then you multiply by 11. So times 11. And it comes out to 17.6, which is exactly what we got over here. Remember, on these types of calculators, you just plug it in backwards, 58 tangent times 11. On these, you type it in exactly as you see it, 11 times tangent 58. Same answer, either way you do it. Okay, let's do number 3 real quick. So number 3, we've got this angle. So what I can do is say that the tangent of 25 is equal to, this side is the opposite, this side is the adjacent. So it's going to be 9 over x. Now this is a little bit harder to do because the x is in the denominator. I can't just multiply by 9 on both sides because x is in the denominator. So what I can do is multiply both sides by x. That would give me x times the tangent of 25 equals 9, and then divide both sides by the tangent of 25. Okay, so I would end up with x equals 9 over the tangent of 25. And that's what I'm going to plug into my calculator. Now again, on these calculators like the TI-30XS, all you have to do is type exactly what you see. 9 divided by tangent 25. It tells us it's 19.3-ish. So 19.3. All right, let's see what would happen on this calculator. This one's a little bit different again. So on this one, when we have division, we actually do have to put the 9 first. So we're going to do 9 divided by, now this is where it gets a little freaky. You do tangent, or 25 tangent, 25 tangent. That's not your answer. That's what the tangent of 25 is. So now you have to hit the equal button. Equals 19.3. There's that same answer that we got there. Now, some people don't like this dividing thing. Could we have done it like the previous problem? Well, there is a way that we could have done it. We could have said, well, if this angle is 25, this angle over here has to be 65. Right? Because all the angles in here have to add up to 180 degrees. So what I could have done is instead worked from this angle. And I could have done the tangent of 65 degrees. Now this one becomes the opposite. So now we get x over 9. And then I can just multiply both sides by 9. And I get x is equal to 9 times the tangent of 65. And if I do that over here, 65 tangent times 9 equals 19.3, which is what I got over here. I'm just doing it from a different angle. So I'm getting the same exact answer. So you can do it either way. You can do it from the angle they give you, or these two angles always end up being complementary. They always add up to 90 degrees. So you can do it from that angle instead. All right, that's all I got for you. Math hard. See you later. Bye-bye.